Alright class, in this lesson we're going to be taking a look at inverse functions, and this is building off of our last lesson of being one-to-one, and that's our first and primary concern. The function has to be one-to-one, and then we can find the inverse. If we don't have something that's one-to-one, we cannot find the inverse. So there's three different types, or different things you'll be doing in your homework. The first type is a relation, and when you have a relation, you just have to trade places with x and y values. Then we'll have equations. Whenever we have an equation that's one-to-one, we trade the x and y variables and then isolate y. You can solve for y. And finally we'll have graphs, and there's a quick way of doing the graphs, and that's reflecting across the line y equals x. So let's go ahead and take a look. This is the same two relations we had in the last lesson, and so you'll first be asked if it's one-to-one, and then if so, you can find the inverse. So here you're looking at this first one, and we already determined last lesson that it is a function because all the x's are different, but it's not one-to-one because we have a 1 here that repeats with this one here. Because they repeat, you cannot find the inverse for that one, so you just say no inverse, it's not one-to-one. In the lab, it's actually really nice and easy. So the second one, it is one-to-one because 3, 0, 2, and 4 are different. 1, 2, 3, and 0 are all different. So our x and y values are different respectively, and I can then find the inverse. And all you have to do is trade places with the x's and y's. So I write a new set, and I can say g -1 would probably be good. Say that's the inverse. By the way, the inverse notation has a little -1. I'll explain it a little better in a minute. And all we do is we take our 3 and 1 and we trade places. So it's 3, 1. Sorry, 1, 3 is trade places. And then in the second one, I trade places here and I get 2 and 0. So 2, 0. And then 3, 2. And finally 0, 4. So that is successfully switching places with all the x values and y values. Okay? And that's your inverse for this first relation that actually is one-to-one. So now we're going to take a look at equations. Now again, you find the equation of the inverse if it's one-to-one. Now we talked about in the last lesson that generally it's odd exponents, in other words odd degree functions that are actually one-to-one. So one-to-one is usually an odd degree, and what that means is that the exponent has a highest power of 1 or an odd number like 3. Okay? Now this one in the middle is an x squared. This is an example of a parabola that shifted up 2. And that is definitely not one-to-one because it doesn't pass the horizontal line test. So this one we won't have to find the inverse for. So if it's an even degree, you probably do not have to do it because it's not one-to-one. Okay? You won't have to do it because it's not going to be one-to-one. Now, for the ones that are one-to-one, like this one because it's a line, and this one because it's that squiggly shape, it would look like that, we do have to actually find the inverse for those two. So let's take the first f of x and solve for its inverse. So first of all, I'm going to rewrite it as y equals 2x plus 5. And now their first direction is to switch x and y, that's step 1, and then solve for y. So there's really only two big steps. So switch x and y, trade places, okay, and I write x equals 2y plus 5. And then your goal is to isolate y. Okay? So now I do that by subtracting 5. And because x and 5 are not like terms, I write x minus 5 equals 2y. And then to finish isolating y, I just divide by 2. And you can divide the whole thing by 2, or a little bit better would probably be divide each individual thing by 2. And that will give me y equals 1/2 x, or x over 2 is the same thing, 1/2 x minus 5/2. Okay? And now, this is the answer, but I can't leave the y there. Because if you look at the beginning of the problem, I have a y up here, and I'm saying y is equal to 2x plus 5. And now I'm saying, no, y is equal to this. Well, we can't can't have two different things that are equal to y in the same equation. We have to say y is equal to one or the other. Well, this is my original y. This one's the inverse y. And so what we do to rewrite this is we actually want to write f to the negative 1 of x. And f to the negative 1 of x is inverse notation. Now, the little negative sign there, it usually, like if you have something like 2 to the negative 1 power, it means that you're supposed to flip it. And an inverse is kind of flipped, okay? So that's why we write this little negative 1 symbol. So basically, we write f to the negative 1 of x is equal to the 1/2 x minus 5/2. And that's my solution for the inverse of this first problem. So the whole process, there's just two steps, and that's switch x and y, and then isolate y. And then at the end, just rewrite it with the inverse notation. Okay? So now we're going to do the same thing with the second problem. So let me go ahead and erase. And now we're looking at the f of x equals x minus 3 to the third power. Now this one's got a little bit more work to it, but still this first step's the same. So switch x and y. Remember, f of x is really y, so it's y equals x minus 3 to the third. And then what you're supposed to do is switch x and y, trade places. So we got x equals y minus 3 to the third power. And we solve for y. We do that, we have to isolate y by getting rid of this third power. We get rid of a third power by cube rooting. The opposite of raising it to the third power is to cube root it. If we cube root that side, then we need to cube root the other side. And then the roots cancel. Sorry for the glitch there, I dropped my pen. Now the root and the power cancel each other, and we're left with y minus 3 is equal to the cube root of x. And now to finish, to get y alone, to isolate it, we just add the 3. And we go ahead and write y equals cube root of x plus 3. Now you could write it that way, or you could put 3 plus the cube root of x. Either way, it's the same thing, just as long as you understand that the 3 is not underneath the cube root. Okay. So anyway, to finish, we rewrite the y, we cross it out, and we write f to the negative 1 of x is equal to the cube root of x plus 3. And now we're finished. So it's a pretty short process. You trade places with x and y, and then you isolate the variable, the y, and then you're done. You've got your inverse. Okay, so now we're going to go ahead and take a look at graphing the inverses. To graph an inverse, we, as long as the function is 1 to 1, we just have to fold it along the line y equals x on the diagonal line. So let me go ahead and draw the diagonal line in there, and then we'll work with some functions. So the diagonal line is this perfectly diagonal line that goes starting at 0, 0, goes up 1 over 1. Okay, and that's the line y equals x, and if you were in mx plus b form, the slope is 1, the y-intercept would be 0. So you can see the y-intercept is at 0, and then you go up 1 over 1 all the way along all these dots. Okay, so that's where that line came from, and that's what we're folding across. So if I was to draw any graph like this one right here, and I wanted to find its inverse, well, what I need to do is fold it across that line. And so what's really nice is if you actually did this on a piece of paper on your desk there in front of you, and actually took a pencil and drew it along this line and like shaded it really, really dark, okay? And then if you were able to just take your paper and fold it so that this corner matched up with this corner right here, and then push it together really well, you would end up with the picture that I'm about to draw. And what that picture should look like is every one of these points would be reflected. So I'm going to be over here. I'm going to take this point and reflect it. I'm going to take this 10 and reflect it up here. I'm going to take this, which is 1, 2, 3, 4, about almost 5, and reflect it over here. 1, 2, 3, 4, almost 5. And then you should end up with this line right there. That is the reflection across the diagonal line. So again, if you folded it and then kind of smeared your paper, you would end up with a shape that looks like this one on your paper. Now notice how I did that. I reflected all these points. So this one was 4 points away from the x-axis, so, or 4.5. Now this one's 4.5 away from the y-axis down there. It reflects that way. the lines intersect at the same point on the graph, and then this point here reflected right over there, and then this point reflected over here. So I'm going to draw a couple more. So let's say I have this graph right here. Okay. Now if that was going to get reflected, then this too would reflect right over here. This point right here would match up right there on the other side of that line. This point right here would reflect right over on this side. And then this, where it touches at -4, would reflect over here. So that's what the graph's going to end up looking like if I connect this dot with this dot, and this dot. It's going to look something like that. So you can see I'm doing the mirror image, and if I folded it, those lines would match up perfectly. Okay? So let's do another one. Now let's say I was looking at this picture right here. As soon as I see this picture, I should tell myself I don't need to reflect it because it's not 1-to-1. Because I can draw a horizontal line and it touches at two places, so it's not 1-to-1. So let's try another one that actually. So let's take a look at one like a vertical line like this one. Okay, this vertical red line should be reflected. It's definitely going to touch right here. This point here is going to touch over here. That's 3 places away, so right there. And then this one is going to touch 3 places away over here. So I just connect these 3 lines, and I've got my horizontal line that is the mirror image. So hopefully this is making sense and you can actually reflect them on your paper. Again, a good strategy is take an actual piece of paper in front of you, draw a grid with your X and Y axis, and then if I was to draw like this red one, I would just shade this in really, really dark with my pencil, and then fold right across the dotted line, have these corners match up, and then you'll actually smear it, and you should end up with this blue line as a smear from the original pencil lead. Okay?